before January 1st, 2000. And so we get this surge in IT investment in the 1990s because every business decided they had to replace all of their computers before January 1st, 2000, which means people who had businesses that otherwise would have replaced their computers in, say, 2001, 2002, 2003, 2004, bunch that investment up, right? They move it forward so they get it done by the end of 1999. And so you get this big surge before Y2K day, and then you get a decline afterwards because all of the investment that would have taken place in 2001 to 2004 got pushed back 3 to 4 to 5 years into 1999. All right, so that's the picture, and that's why this sharp decline that starts here. And I don't know why my picture stops there, so I will have to go back and investigate. Because you know what I did? Oh, I know what I did. When I redid the graph, I forgot to change the settings. So I changed the year part, and I forgot to tell it to grab the next 10 years worth of data for the rest of it. Well, I'll fix that. I know. No, yeah, exactly. It's like me and Rogoff and Reinhardt's RA. I didn't drag and drop far enough. Fix IT graph. I'll fix that and repost it. Okay, so Styro's article. Styro's article says it's all IT. Well, not it's all IT, but it says a lot of it's IT. So this is a picture from the article. I know that the reprint in the reader is not all that great. It's the best I can do. I don't know why it's such a bad original, but it just carries through. The dot-com boom? No. So the dot-com boom is, to the extent the dot-com boom is associated with people buying not hard frame, what's it called? Big frames. The big computers are called mainframes, thank you. To the extent that it's associated with them buying humongo computers, yes, that would be up here in the IT share of investment. Dot-com boom is lots and lots of whatever dot-coms being formed, many of which had no business plan whatsoever, but nevertheless people threw a whole lot of money at them. Okay, here we go. So this shows the same story that we've just been telling. It shows the different average rates of growth of productivity in the different periods. Notice that this is ending in 2000, so this article is about 8, 9 years old at this point. But I wanted you to read one that was written during the exciting period before people said, let's talk about something else since we don't understand what's going on. So Styro takes our standard production function and breaks it out just a little bit differently. So instead of just output, well, actually I don't need that part, but I'll put it down. Instead of just output, he distinguishes between the output from investment technology and the output from everything else. So the output from investment technology, just to make sure that we're really confused, gets relabeled as I sub IT. I was like, why? I don't know. And the Y sub N, it would be so much nicer if it was called Y sub non-IT, but it's just called Y sub N, so you have to keep looking back and forth in the article to see what it is. So that's the same thing. Takes capital, the capital that we've had, all the K that we've had all the way along, and splits the capital into capital that is investment technology, so the machines that are computerish machines, and all other, so the non-IT capital, which he calls K sub N. Yeah.
So IT is information technology?
Yeah.
Like investment technology?
That's why the I is, you mean why the I up there? So the IT is I, information, T, technology. And then but the word income starts with an I. So well, that's one explanation. So the Y, remember that Y is both, let's see, I don't know if that thing is, oh my God, what is that? Go away. I don't want to write there. Y stands for both income and output at the same time. And the output can be consumption plus investment plus government plus net exports. And so the output that is the output of IT is going to all be categorized in the investment part of C plus I plus G plus net exports. So that's why he labels it as I sub IT. Yeah. It's just to make sure you're confused. Okay. All right, and then we're going to have L, which is to labor, and we're going to have H, which is hours. And then we're going to say, look, instead of having output be just a function of capital and labor, we're going to say this total output is our total factor productivity A times some function that combines, in this case, capital from the IT sector, capital from the non-IT sector, and labor. So it's similar to, I said earlier, instead of having K and T, or K and L, we could have government capital and private capital. So this is the same, we have IT capital and we have non-IT capital. And if we assume that this is a Cobb-Douglas production function, a Cobb-Douglas production function is one where you have A times the factor, K sub IT, raised to the power alpha, times K to the sub N, raised to the power beta, times L, which is just L by itself, raised to the power gamma, alpha, beta, gamma. And what makes it Cobb-Douglas is not only that form, but also that alpha plus beta plus gamma sum to 1. So if those parameters, exponents, alpha, beta, and gamma, if those things add up to 1, we've got a Cobb-Douglas production function. It exhibits constant returns to scale, so if you double all of the inputs, you'll get double the amount of output. And lo and behold, those exponents, the alpha, the beta, and the gamma, they also measure the share of that input in total income. So that alpha winds up being, give or take, equal to IT's share of total income. And beta winds up being, give or take, K sub N's share of total income. And alpha, beta, gamma winds up being, give or take, labor's share of total income. And we can take this whole equation, and I could divide through by something if I wanted to. And in fact, I'm going to divide through by the number of hours. I'm going to run out of space here. Can I erase the definitions I just wrote down? Got them? Holler if the answer is no. Okay. Because I'm running out of space. Erase. Cool. Pen. So I can transform this equation, and I can get Y over H, which is output per hour, is equal to that constant A times parentheses K sub IT over H to the alpha times parentheses K sub N over H, closure parentheses, to the beta, times parentheses L over H, closure parentheses, to the gamma. And that's just a straight off math transformation. Since alpha plus beta plus gamma equals 1, then if I divide by H in each of those three pieces, it's the same thing as dividing by H on the left-hand side. And then I could do a little calculus. I'm not going to do the calculus, but I could do the calculus where I could take the derivative of the log of this thing, and then I would get our lo and behold result, which I'll put in a new color just to make it exciting, which is that the rate of change of output per hour, so per worker hour, is equal to the rate of change of A, so the rate at which total factor productivity is growing, plus alpha times the rate of change of parentheses KIT over H, close your parentheses, plus beta times the rate of change of parentheses KN over H, close parentheses, plus gamma times the rate of change of parentheses L over H, close parentheses. Since alpha, beta, and gamma equal the shares of each of these inputs in total income, then I can just get some data together and I can come up with estimates for the value of alpha and the value of beta and the value of gamma. And then I can use this equation. I can start plugging in values of things in this equation. So I can plug in what actually does happen to output per hour, and I can plug in what actually does happen to labor per hour, and I can plug in what actually does happen to K over N per hour or K over IT per hour. And then I can back out of it my estimates for what's happening to total factor productivity. Because total factor productivity is the thing we've talked about all semester. It's the thing that's not really directly measurable, right? I mean, we talked about the development of banking contributed to total factor productivity. How are you going to measure that, right? The National Banking Act increased total factor productivity. How do you measure that? And I always said, I waved my hands, I didn't really tell you. Now I'm telling you. The way in which they measure total factor productivity is by assuming a particular functional form, in this case Cobb-Douglas, by coming up with measurements of the shares of each of the inputs in total output, that's the alpha, the beta, the gamma, by measuring what's happening to the rate of growth of output per, in this case, hour, and what's happening to the rate of growth of the three other pieces, and then plug back out the value of percent change A. Why do we split up K? Because in the table I'm going to show you, he also wants to make a distinction between the contribution of IT capital and non-IT capital. Yeah. So just to get percent change A, I wouldn't have needed to, but to make a bigger point about the role of IT is why he split those things up. All right. So what do we get? This table is not in any handout because I just realized at 1:30 that I needed it. So it's there. I reloaded the slides at 1:30, so anybody who pulled the slides up at 2 should have it in their slides. But otherwise, you'll just have to reprint this page when you get back home. In the article, there's a table where he reported the results from 5 different studies of productivity growth. So what does the BLS say? What did Jorgensen and somebody else say? What do these 5 different scholars say? So what I did was I just simply took the arithmetic average of those entries. Okay. So the numbers here, each of these numbers is the average of the 4 or 5 entries that are reported in his table 1. So I just think it's easier. I just thought it would be easier to see what it is that he's saying. And so the first column shows you what's in the first 2 rows of that table, and it shows you what's the increase in the rate of growth of output per worker in Y over L. And so the rate of growth of output per worker, if you look at the 1973 to 1995 period versus the 1995 to 1999, I think it is period, is on average is a 1.2 percentage point jump. I forget, it's like from 1.4 to 2.6 or something like that. Then we're going to take and we're going to break that 1.2 percentage point jump up into its pieces. And so you'll notice 1.2 equals 0.5 plus a negative 0.1 plus 0.1 plus 0.3 plus 0.4. So the table is showing you of the total jump in productivity growth, which part's coming from which piece. So we got a 1.2 percentage point jump in productivity growth. What's coming from what piece? Capital deepening is the greater use of capital. So, golly, I used to teach with just an overhead, and notice I'm now teaching with an overhead and a computer. Capital deepening. I now use the overhead as a tray. Not sure how well that works, but nevertheless, that's more capital per worker. So capital deepening and increasing the amount of capital, that's going to increase average labor productivity. So ALP, average labor productivity, that's the Y over L, remember. So that accounts for about 1/3. Where do we get that? Oh, here, yes. The capital deepening is, I'm going to circle this, I'm going to erase my circle in a minute. 0.5 plus a negative 0.1 is 0.4 percentage points of the growth in productivity growth. So 0.4 percentage points of the jump comes from capital deepening, more capital per worker, more capital per hour, and 0.4 over 1.2 is about 1/3. So that's the source of the conclusion that the capital deepening, more capital per worker, is about 1/3 of the jump in productivity between the slowdown period and the revival period. The remaining 2/3 comes from the labor quality and the total factor productivity. The change in labor quality is only 0.1, so we just ignore that and focus on the total factor productivity. So that be something like this. The total factor productivity gains, about some green, does that work? Here are 0.3 plus 0.4, that's 7. 7 out of 12 is about 2/3. So about 2/3 of the gain in productivity pre and post 1995 comes from gains in total factor productivity. And then the question is, well, how much of this is from IT and how much of it is from other things? In that case, you want to look at these numbers differently. I'm going to erase all of this ink. And now I want just the IT pieces. Oops, that was silly. I want the IT pieces. So how much of the growth comes from information technology? Well, we've got 0.5 percentage points of the growth are coming from the greater use of computers in your job. So there are more computer checkouts at Lucky's than there used to be. More people are working with computers in their jobs. So the increased use of computers in people's jobs, so more capital per worker. And then the 0.3 part, that's the, you don't really know how to measure it, but somehow it's the role of IT in increasing productivity generally. So in the non-measurable, calculated as the residual, the leftover part must be there because the math has to work out, right? Part is 0.3. That gives me a total of 0.8. 0.8 out of what? 1.2 is about 2/3. So about 2/3 of the productivity growth is due to IT. Some of that is more computers, and some of that is better, faster computers. So the 0.5 is more, and the 0.3 is better, faster. Okay, I'm doing good. Yeah. I'm sorry, I can't hear you. There is a negative there. Yeah. So the negative is there because the, how would I say, capital lessening. So people were using more computers, but less of other forms of capital. Yeah. So that the use of other forms of capital was actually making productivity worse. Yeah. Other questions? All right, so what's the takeaway? Computers important, yes or no? Yes. Okay. All right. Now, here's just a little table. This one you do have in the handout from last time. That, I don't know how I'm going to tie it into the story. I mean, I could tie it into the story. I just mostly want you to see it. And because this is using the very finely defined classification system. So these are 4-digit standard industry classification codes. So really well-defined industries. And what I wanted to show you was, for instance, how rapidly, so here's the heyday. The heyday is, let me do here, is 1995 to 2004 is the real heyday in terms of productivity growth. And you can see it in manufacturing of computer and electronic products. You can see that the productivity growth in that 10-year period, those 2 5-year periods, is certainly on average greater than the productivity growth before, and particularly greater than the productivity growth after. But I just find it fascinating to look at the contrast here. So electronics and appliance stores. Best Buy, for instance, that one still exists. There are a lot of other electronic stores that no longer exist that were in this category. Food and beverage stores, Safeway, Lucky's, Andronico's, Trader Joe's, and so on. And look at the difference. The increase in output per hour in electronics and appliance stores, on average about 15% increase in output per this is output per hour. In the heyday, grocery stores. It's pretty hard to increase productivity in grocery stores. I mean, milk is milk, right? You're going to go in, you're going to get some milk, you're going to get some Cheerios, you're going to get some bread, you're going to get some toaster muffins. What are those things called? Pop-Tarts, that's the one. When we went to Australia some years ago to see some friends who had lived in the U.S., and before we left, Lynette sent me an email and said, please, would you go to the store and get me this kind of Pop-Tart, because they don't sell them in Australia. So it's like, I filled my suitcase up with Pop-Tarts. It was a very funny thing. Anyway, grocery stores, not a lot of gain there. Clothing stores, some increases in productivity, probably from increased use of computers for inventory control. Other general merchandise stores, so that's going to be your Costco-type places. Electronic shopping and mail order houses, so there's Amazon is in the very far right-hand corner. So the online, as well as the good old-fashioned LL Bean and Land's End, which were mail order before there was online. Very strong productivity growth here as well during the heyday period, and not so strong afterwards. So that chart I just wanted to show you because I think it's interesting. All right, so here's the question. Were there technological developments in the past that are analogous to IT? And if so, what's the analogy? So what are the parallels? So this is a group work thing. There you go. So yeah, I know, because they said, we haven't done any group work in a while. Oh, yeah, that's right, we haven't done any group work in a while. So now we're going to do some. So what I want you to think about is now we're on like week 13 of the class, right? Something like that, week 12, week 13, we're near the end. So we've talked about productivity the whole dang semester. I mean, did I talk about Clovis points and Folsom points on the very first day? Yeah, productivity. So what are technological developments in the past that might be analogous to IT? And then your group's task is to figure out what's the analogy. So what makes it analogous? So do you guys think these are 3-person groups or bigger groups? They think 3? Okay, so we'll do the same thing. So each row along here, if you're in by yourself, join up or down, is a group. 3, 4, something like that. That works fine. And then here we'll do the first 4 seats are a group. And let me think through this way. These 4 seats are a group, give or take. And what do I have left? 1, 2, 3, 5. So the middle 5 seats are a group, which works out to be groups of 3 or 4. You guys are a group. And then you guys are a group. So Emily, you got to turn around and join the guys behind you.